Good morning students. So today we are going to discuss the doubts of exercise 1.3 that you asked. Okay. So the topic is the number system. So up till question number 4 I discussed. Okay. 5 is also the same as question number 4, right? Divide and find, check the terminating or non-terminating decimal. Now using the question number 6. Look at the several examples of a rational number p by q. P by Q represents a rational number where P and Q are integers, right? And Q is not equals to 0. So look at several examples of rational number. So we have to write several examples of rational number, right? And which type of? With no common factors other than 1. With no common factors other than 1 means we have to write those rational numbers which cannot be divided further. That is SCF is 1 of both the numbers, or you can say in other words the fraction should be in simplest form, right, which cannot be divided further. And having terminating decimal representation. So can you guess what property Q must satisfy? So we have to write the fractions is that it should be of terminating decimal type. Okay, so I am considering some fractions. So consider p by q as the first example 1 by 2. So 1 or 2 are, this is a very simplest fraction which cannot be divided by the other numbers except 1 and 2. So 1 by 2 is what? 0.5. This is what? Terminating. As in the question this is given, we have to give the several examples which are of terminating decimal type, and the fraction should be what? As simple as, that is, it should be in simplest form. Next, I am taking 1 by 5. So divide this point, then 2. This is also what? Terminating kind of decimal. Okay. Next, third example which I am taking 1 by 10. So what I will get? 0.1, again terminating. Okay. Next, fourth example, as we have to write several examples, 1 by 4. So what I will get? 0.25. One more example, 1 by 25. So what I get? 0.0. Okay, we can show also the division. Decimal 0, then 0 and 4. So 0.04. So all these are what? The simplest form. They are in simplest form. And every time we are getting terminating. Okay, this is also the terminating decimal type, and this one is also terminating decimal type. Clear? So now we have to observe the pattern. That is what we can conclude about this Q. Q is what? Denominator. So see here, denominator is what? That is the value of Q. Here Q equals to 2, and in this part Q equals to 5. Here Q equals to what? We can say 2 into 5, right? 2 5s are 10. And similarly in this fraction, what is the value of Q? Q is 4, that is 2 square, 2 into 2. Or in this, what is Q? 5 into 5, that is 5 square. So what we are observing, that for terminating decimal, right, in order to have terminating decimal, the denominator, that is Q, must be of the form what? The factor of 2, that is here, the factor of 2 only, factor of 5 only, or factor of 2 and 5 only, and here we can say the exponent of 2, that is 2 square, even 2 cube, 2 to the power any number, 2 to the power 3, 4, 5, any number can come, then you will see the number must be terminating. And same as here 25 is coming, so 5 square. So here again the 5 exponent, that is 2 is coming. So by looking at these several examples, we can conclude for terminating decimal Q must be of the form 2 raised to the power n or 5 raised to the power n, where m and n are whole numbers, or you can say non-negative numbers. Sometimes n may be 0, so we will get only 2 to the power something. That is the example of this. Same as if n is 0, 2 to the power 0, then this becomes 1. So we have the power of only 5. So it means the fraction should contain the denominator as the number 2, only 5 only, 2 and 5 both, or its highest power of 2, that is 2 to the power 2, 2 to the power 3, and so on, right? So this is a very important characteristics for the terminating decimal of a rational number. Okay, so this was the solution of the question number 6. Now question number 7. Write 3 numbers whose decimal expansions are non-terminating and non-recurring. So non-terminating, non-recurring means irrational number. So we already discussed about irrational number and its examples. So write any 3 examples. So I am writing the 3 numbers, okay, irrational number, and you will write its different type, okay. So see the pattern. This is the example of non-terminating and non-repeating, because dash dot is going on means non-terminating, and non-repeating means here 100, here is 10,000, then again the numbers, that is 0, 20, here 10, 30, 40, okay. So 0 is what? Extending. It means the digits, no set of digits is repeating. Same as another example, you can say 2 point something, 2.02, then 002, even you may change the number 3 I have taken, then please 404, and so on. So write the any numbers, okay. Same as third, you can write your all the examples of irrational numbers. Now question number 8. Find 3 different irrational numbers between 5 by 7 and 9 by 11. So we have to find 3 different irrational number. So we have come to know what is the pattern of irrational number, non-terminating and non-repeating. Now we have to write the irrational number in between this, that is, this is the range. So first of all we have to simplify this, that is, we have to get this number in decimal form. So divide this point, then 0, 7 7 is 49, then 1 0, or 7 1 is 7, and so on, okay. That is, this is just sufficient 2 places, okay. And for this 9 by 11 and this 9 by 11, 0.11 8 88 88 or 2 0. So 11 1 11. You can show in a rough calculation if you want. So I have calculated directly. So 5 by 7, that is 0.5, 0.71, and 9 by 11 means 0.81. So we have to write the irrational numbers like this number in between 0.71 and 0.81. So there are as many as numbers. For example, first we can say 0.75, 01, 002, 0003, and so on, okay. In between this, same as you may take another numbers 0.76, 01, 001, 000, and it, so and so on, and you can find as many as numbers, okay. Make sure the number must be smaller than 0.81. So 0.80, 0.79 dash dash, okay, 001, 002 something, you can consider the examples. So this was question number 8, and question number 9. Classify the following numbers as rational or irrational. So we have to find whether the number is rational or irrational. right? So 23. So first of all, look at the prime factor of 23. So since 23 is what? A prime number, right? So the prime numbers are those numbers which are what? Divisible by itself and 1. So the prime factors of 23 is what? Itself the 23. And in square root you studied in previous class. For simplifying this square root, we should have what? We make the pairs of numbers and then we write one numbers outside of the square root. So here this 23 is a prime number. It means which cannot be factorized, okay, and we cannot have prime factor of this number itself 23. So under root 23 is a irrational number, because irrational number, if there is a square root, right, and it cannot be factorized, so the number must be irrational. Okay, some examples I already discussed, like under root 2, okay, cannot be simplified further, under root 3, under root 5 and under root 4 I have skipped. Why? Because under root 4 is expressed as 2 into 2, then we make pair and only 2 will come, and this is what? 2 by 1, so it becomes a rational number. So make sure we can say that this 4 is the perfect square number. So it means if inside the square root any perfect square number is coming, like 4, like 9, 25 and so on, if perfect square number is coming, then the number becomes what? Rational. So 23 is what? Not a perfect square number. Okay, this is a prime number, so that's why this is irrational number. So we have to justify the answer also. Okay, do not write straight away the answer. Now the next part is under root 2 to 5. So this time the number is large. So how we will solve it? So we will solve it by using prime factorization method. So clearly the number is divisible by, let's start with 3, because 5 is coming, so number is not divisible by 2. So 3, 7, 21, then 3 5s are 15. 3 further we can divide. I am sure you must have solved this kind of prime factorization in previous classes. So solve it. If you have doubt, you may ask. So 2 to 5 under root or square root can be written as into 5. So now we make pair of 2 and 2. Because in the square root we make pair of two numbers and we write as the number is in the square root. So while we take this out, so we write only one number from such pairs and one number from 5. So 3 5s are 15 and 15 is what? Can be written as P by Q form. P by Q form. So hence this number is what? Rational number. So this is the example of irrational and this is what? Rational number, right? Third one is 0.3796. 0.3796. So you will write clearly the number is what? Terminating decimal. And we know that each and every terminating decimal number is what? Itself rational number by the property of rational number. So it means what? This implies this is what? Rational number, because the number is what? In terminating decimal form, right? So I hope you got about rational or irrational number. And now we are showing the representation of a number on the real line or number line. So let's learn this concept also. Exercise 1.4. In this exercise we will visualize the number, right? So how? See, question number first, the number is 3.765. So we have to visualize this number by using what? Successive magnification, right? So this number has to be represented on number line. So number line is what? If we draw a line, first of all, learn about number line. Put a arrow, select 0 in the middle, 1, 2, 3, 4 and so on. Similarly this side negative numbers, -2, -3 and so on. So this is called number line, which contains a line as well as numbers on it, having some equal distance, equal gap. Okay, so this is the number line. So we have to show this number 3.765 on this number line, right? So if I say locate the number 3 on the number line, so clearly this is the answer, that this number is what? This point, you can say this point P is the representation of number line, that is the number 3. Same as if I say represent -2 on number line, so you will highlight this point, that is -2 is showing on the number line. Same as we have to show 3.765 on the number line. So see, the method is, let's start from this. Clearly we have to see the number is 3 point something, so this number must be greater than 3. Are you sure? 3.765 means number is greater than 3 and it must be smaller than which number? 4. So it means we conclude this number is clearly lying between 3 and 4, because it is 3 point something, and 3 point something means the next integer will be 4. So it is definitely less than 4. So we know this thing. Now we make it's a division, that on the scale, as you know, 1, then on the scale 2 comes after some certain divisions, but in the number systems there should be 10 divisions to get the 4. So from 3 to 4, how can you approach? There are 1, 2, 3, 4, 5, 6, 7, 8, 9 and this one is the 10th part. So to get 4 and we have to start from 3, so this number is representing 3.1. Next division can be taken as 3.2, because numbers now coming in decimal. So this is 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9, and we are very sure after 3.9 the next number must be 4. Clear? So now after decimal, now see the number is what? 7. So now find where is 3.7. Here is 3.7. So this number is greater than 3.7 and smaller than what? What is the next number? Just next, this 3.8. So we can encircle this, that this circle ensuring us this number 3.765 must be greater than 3.7 and this is smaller than 3.8, because after 3.7 3.8 will come, just next number. Okay, so now what we have to do, right here this 3.7 what I have encircled, and the last one is 3.8. Again divide this 9 segment into this small 9 divisions having equal gap, 2, 3, 4, 5, 6, 7, 8, 9, and the next one is itself 3.8. So this number must be 3.7, we can say 1, because this is the first part of the decimal. Okay, next 7.2, 7.3, 7.4, 7.5, 7.6, this number is going to be 3.76. Next one is 3.77, next 3.78, or next 3.79, and after 3.79 exactly we will get 3.8. Okay, now one more step to go. You can write here 3.74, 3.75. So now till 3.7 we have taken here. Now the next number is what? 3.76. So where is 3.76? Here is 3.76. So this number is what must be lying in between this 3.76 and just next number is what 3.77, and you can clearly check this number is greater than 3.76 and smaller than 3.77, because this is 3 places of decimal and we are taking 2 places, so the number must be lying in between this. So next we will visualize this, that is magnifying 3.76 or 3.77. okay, now again 1 2 3 4 5 6 7 8 9, or next number will be 3.77. so this decimal indicates actually 3.761, next division 3.762, next division 3, next 4, and this one is 3.765. now see the result 3.765. so this point is representing 3.765, right? So this is how that we can show or we can visualize this number on the number line. So representation of decimal on the number line can be done by taking the numbers, right? And we have to go decimal by decimal. First of all, first place, then 2 places, then third places we will get the number. So this is the answer. Now try to solve the question number 2, and if you have doubt, ask me this doubt. Okay, thank you so much.